All right, so we're back with homework number 20. A little bit easier one this time, I think. And so this is dealing with complex fractions, which basically is a fraction divided by a fraction. And so, for the most part, except for the last one, I'm going to choose to rewrite these as a division problem, which is really what they are. And we'll talk about why I'm not doing that to the last one when we get there. But I would choose to do this. Um, this fraction bar here just basically tells us that that top fraction is being divided by that bottom fraction. And so just like with regular fraction multiplication, we need to do the reciprocal of the second fraction and put a multiplication sign in the middle. So we will have 7/16 times 14 over 5. And if we do the cross-canceling gig, my darn iPad disappeared. So if we do the cross-canceling gig, we get divide both of those by 2. That makes an 8. That makes a 7. And so we will end up with 7 times 7 is 49. 8 times 5 is 40. So 49 over 40 will be our final answer for that one. On to number 2. Similarly to number 1, that means to divide those two fractions. So I will write it out as a division problem. Again, the reciprocal of the second fraction, and then we multiply them. And so we can cross cancel like crazy. These x minus 5s will disappear. That makes a 1 and a 1. The 3 will divide out of the 12 to make a 4. That x squared is going to be divide out and make just a 1 up there. And then x to the third is just going to become x. And so what we've got is 1 times 1 in the numerator is 1. 1 times 4x in the denominator is just 4x. And so for number 2, 1 over 4x is going to be our final answer. Okay, moving on to number 3. Same situation as last time. We have x over 4x plus 16 divided by x cubed over 12x plus 36. And so we're going to do the reciprocal and multiply again. So that becomes times 12x plus 36 over x to the third power. We'll do our cross-canceling gig. That's going to become a 1. That's going to become an x to the power of 2. And actually, I take that back. I'm going to have to factor first before I can really do some cross-canceling. So let's take the denominator from the left, the 4x plus 16, and factor it. That'll be 4 times x plus 4. The one on the right, the numerator on the right, 12x plus 36, a 12 can come out, leaving x plus 3. And so we'll rewrite it like that. So x over 4 times x plus 4 times 12 times x plus 3 over x to the power of 3. Now we can start doing some cross-canceling. So again, that x is going to cancel and become a 1. That 3 is going to be reduced to a 2. The 4 and the 12 will cancel, making that a 1 and that a 3. And I think that's all we can do. So what we've got in the numerator is 1 times 3 is 3, and then the x plus 3 is still there. And in the denominator, we have an x plus 4 on the left and an x squared on the right. So I'll write it as x squared times x plus 4. It's kind of a weird one there. Yep, and so that's the way that one's going to go. Kind of a strange answer on that one. So number 4. Similar situation, we've got 4 over v plus 6 divided by 12v over v squared plus 12v plus 36. And so again, reciprocal and multiply. And so we need to factor that numerator on the right. So let's go ahead and do that. V squared plus 12v plus 36. Factors of 36 are 1 and 36, 2 and 19, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. So we need to make 12. And so the 6 and the 6 will do that. So we've got v squared plus 6v plus 6v plus 36. On the left, we can factor out a v. On the right, we can factor out a 6. They both have a v plus 6, so we can factor that out now. So we get v plus 6 times v plus 6. So we'll replace that in here. And now we can do our cross-canceling gig. Our v plus 6 will drop out, 1 on each side there. And then our 4 will become 1. Oh, and that becomes a 1 in the denominator also. 12 divided by 4 is going to be 3. And so what we've got is 1 times v plus 6 makes v plus 6. And then 1 times 3v makes 3v. So v plus 6 over 3v is what we end up with here. Now this last one is a bit of a mess, and I don't particularly like this problem. I will tell you there's not going to be one like this on the test. But I'm going to go ahead and leave this one as the nasty looking fraction that it is, because if we look at that denominator and we study it for a moment, we can see that that denominator is a difference of squares. And so what we're going to do we can see that 25 is a perfect square, so is x squared. There's a subtraction sign in the middle. It's a difference of squares. And so if we factor this denominator, we would get 1 plus 5 over x and 1 minus 5 over x. Now again, there's not going to be one like this on the test. I think this problem is kind of like a bit too heavy, but is what it is. So numerator and denominator, we can cancel the 1 plus 5x there with the 1 plus 5x there. And we would be left with 1 over 1 minus 5 over x. And that's an acceptable answer for me. You could continue with this. So I'll box that guy in. You could keep going. And the way that you would keep going is that we would need to do the subtraction in that denominator. So we would need to create a fraction that has two fractions that have common denominators. And so to do that, we would need to multiply 1 by x. So we would have x over x minus 5 over x. And what we need to do at that point would be to go ahead and do the subtraction in the denominator. Since the denominators of the fractions in the denominator are the same, we can do that. So we get x minus 5 over x. And it's crazy to say the denominator is inside the denominator. Like I said, this is a little bit over the top as far as I'm concerned. And then what we would have is, then I could write this out as the division sentence, 1 divided by x minus 5 over x. Then I could change that to multiplication. 1 times x over x minus 5. And 1 times x over x minus 5 is just x over x minus 5. That's another acceptable answer. I'm not sure if Alex will accept both of those or not. I would accept both of those, but like I say, this last one, there's not going to be a question like this on the test. I promise.